turn to squaring and rooting. You can't really see it very well, but it says squaring and rooting inverses. And you already have a calculator? If not, grab one real quick. Somebody took yours? I left yours there, but somebody must have grabbed it. All right, what we're going to do on this first thing is we're just going to graph y equals x squared right here. Okay, and so when we plug -3 into x, what's -3 squared going to be? 9. -3 times -3 is positive 9. What about -2 squared? 4. -1 squared? 0 squared? 1 squared is? No, it'd just be 1. 1 times 1 would be 1. 2 squared? 4. And 3 squared? Okay, and then we'll graph these points over here on the graph. So -3, 9. -2, 4. -1, 1. 0, 0. 1, 1. 2, 4. 3, 9. Is this a function?
Yes.
He says yes. Y'all agree?
Yes.
How do you know?
Because no x repeats.
It passes the vertical line test and no x's repeat. Okay. So we're going to put,
I got 9 at the top.
huh? Oh, what would be
You're writing
the,
it down on the range.
you are right. Whoops. Whoops, it's a function. And what was your other question?
It says what is the range.
No, I know, but somebody said something
Oh,
about
no.
it. You're okay? All right. We're going to put passes the vertical line test. Then we'll go back to the range.
Does mine goes to the top? That's what I was talking about.
What now?
It does. Your
have
3
your dots
9's
off.
off.
Oh. I just figured that was 10 things. But it's not, is it? That's why it looks weird. That looks better.
Good job.
Okay, if the domain of the equation is -3, -2, -1, 0, 1, 2, 3, then what would be the range?
9, 4, 1.
Okay, let's go in order, least to greatest. 0, 1, 4, 9. Okay. Where'd you find that? Okay. Well, she told me she didn't see
The other
it.
one's not in there.
I said, did you see my deal? She said, no, it's not there. Okay, thank you.
I didn't see the other one though.
Okay,
Well,
Since
appreciate
we
it.
specific points where the range
Yeah.
and the domain errors, shouldn't we not have the errors on the graph?
We shouldn't even have it colored in,
Oh,
actually. If you're looking at really the domain and range of the equation, you would not put points, would you? You wouldn't. What's the domain of a quadratic? All real numbers. And then what would be the range of this quadratic?
Is greater than or equal to 0.
0. But since they gave us a specific domain, then we had to give them a specific range. Okay, that's why it's different. So they just gave us those 3 points. This would be the range for it. Okay,
So should
and I understand the confusion there. Okay.
we dig up the line?
No, it said to graph it. We graphed it. It didn't ask us the domain of this graph or the range of this graph. It asked us the range of this domain right here. Okay, that's the difference. All right, now what we're going to do is the inverse. Now remember at the beginning of the year we did inverse. You know how to find that?
You switch X and Y.
Switch X and Y, very good. It's hard to remember that, but that's what you do to find the inverse. So they put all the X's in the Y column, so we're going to put all the Y's in the X column. So we'll have 9, 4, 1, 0, 1, 4, 9. Okay? And then we'll graph it, see what it looks like. So we're going to go over 9 and down 3. Then over 4 and down 2, over 1, down 1. Let's keep going.
It's not a function.
That's for sure. What does it look like?
It's been rotated.
It's been, yeah, it actually hasn't been rotated though. It's really been
Flipped across
reflected over what
the
line? Do you remember?
x-axis.
Or Y equals X.
Y equals X, this linear parent function line right here. It's reflected over that, okay? And it looks like a sideways quadratic, doesn't it? Okay. Right, is it a function?
No,
No. And why not?
because it does not pass the vertical
Right.
line.
Okay, fails the vertical line test. Okay, it fails the vertical line test. And that means if you draw a vertical line, it's going to cross it more than once. Okay, so inverses do two things. They switch X and Y, and they reflect over which line?
Y equals X.
Y equals X. Okay. Now we're going to look at the inverse of this same quadratic, but we're going to do it algebraically. So our first step would be to switch X and Y. So we're going to write X equals Y squared. X equals Y squared. That's actually the equation of this quadratic right here. Or this not a quadratic. Okay, and then we're going to solve for Y. So I'm going to rewrite this again. X equals Y squared. I want to get Y by itself, so I want to get rid of the square. How do you get rid of a square?
Root it.
Square root it. Or square root both sides. Okay, and then when you square root variables, what do you have to put out here in front?
I
Plus or minus.
Plus or minus. It would be I if we were square rooting a what?
negative.
Negative. Okay. What's the square root of Y squared?
Why?
Y. The square root and the square cancel out, and we just have Y. Okay. All right, so before we write this down here, I want to sketch this. We're going to draw coordinate axis over here, the X and the Y axis, and then we're going to graph it in your calculator. And we have to put plus or minus in the calculator, but we can't. We don't have a plus or minus button, so how could we put it in there?
Positive square root of x and negative square root of x.
Okay, so we'll do the positive square root of X in Y1, and then the negative square root of X in Y2. Everybody plug it in.
It's in my calculator to begin with.
It was, okay, yeah, so it's probably already in there, isn't it? Graph it. And what does it look like? Does it look like what we got in number 2?
Yeah.
Yes. So we'll sketch it. And what's the problem with this graph?
It's not a function.
It's not a function. Right. So down here where it says, what's the problem with this graph? This graph is not a function. That's a problem. How could we make it a function?
Rotate.
Okay, but then it wouldn't be square root of X anymore. Could we get rid of some of it?
Yeah.
What part would be a good part to get rid of?
Negative.
The negative part. If you get rid of the negative part, would it be a function? Yes. Okay. And that's what we're going to do. We're going to get rid of the negative part and just have the positive part. So this is another way to write function. This is function notation. This means the inverse of f of x. The inverse of f of x would be the square root of x. We can't put plus and minus because then it wouldn't be a function. So we just put the positive part. Okay, everybody got that part? Now when you turn the page, it says, so normally we just graph the top half and call it the square root function. So the top half is the square root function. And we're going to look at the parent function. There it is, the square root of x. And here's a table. When you plug in 0, the square root of 0 is 0. And when you plug in 1, the square root of 1 is 1. And the square root of 4 is 2. Square root of 9 is 3. What would be the next one? That's whole numbers.
16.
Square root of 16 is what?
4.
4. Okay, and then what would be the next one?
5.
Square root of 25 is 5. Okay. We could keep going. Square root of 36 is 6. Or square root of 49 is 7. Okay. We're going to graph this. 0, 0, 1, 1, 4, 2, and 9, 3. And then draw the curve. And that looks like the square root that we had yesterday. Except ours was a little compressed or stretched or something. It was compressed, wasn't it? All right, and the domain of this, where does the x start at?
0.
0, and it goes which direction, right?
Yeah.
Okay, so we would say x is what?
Greater than
Or
Equal
equal to 0. Okay. That means that you can only use positive values if it's greater than or equal to 0, as those are positive values for x. Why can't we use negative values?
Negatives can't be
Square root of negative. You get an imaginary number instead of a real number. Okay. What about the range? Where does the y start? 0, and it goes up or down? Up. So y is okay. And you can only, if you only put positive numbers in here, then you're only going to get positive numbers out. So you will only get positive answers for y. And that's just for the parent function. When you transform them, move them and everything, then it changes the domain and range some. Okay, we're going to work on some inverses using algebra. We did it graphically, we did the inverse. Now we're going to do it with algebra.
well, that's
We're going to replace f of x with y first. So this f of x is going to become y equals parentheses x minus 5 squared. What kind of a function is this that we're starting out with?
Quadratic.
Quadratic. Okay. What's the inverse of a quadratic? A square root. We should end up with a square root. Okay. Now the next thing we're going to do is switch the x and the y variables. So we'll have x equals parentheses y minus 5 squared. Okay, then we're going to solve for y. So we want to get y by itself. We're going to have to get rid of what? What do we need to get rid of? The square and the 5. Which one do we get rid of first?
Square.
The square. Okay, we got to go by the rules of order of operations. The PEMDAS rules, parentheses, then exponents, then you add or subtract. So we're going to get rid of the exponent. How do you get rid of the 2? Get rid of a square by square rooting both sides. And we're not going to put plus or minus because then it would not be a function. So we're just going to use the positive square root of x. And the square root undoes the square, and what do you have?
1 minus 5.
Y minus 5. Okay, now we got rid of the square root. What do we have to get rid of next? So how do we do that? Add it. So we have square root of x plus 5, and the plus 5 is outside the square root, equals y. Our last step is to replace y with the function notation for inverse. So we're going to have f to the negative 1 of x equals the square root of x plus 5. And that will be our final answer. Did we end up with a square root?
Yeah.
Yes, we did. Started out with a square, the inverse would be a square root. This time we're going to start out with a square root. What's going to be the inverse? A square or a quadratic. So we replace f of x with y. So y equals the square root of 3x plus 2. And then, what do you do next?
Switch x and y.
So x equals the square root of 3y plus 2.
Wait, don't we have to switch the sign?
What sign?
The X and Y.
No, you just switch X and Y. We didn't, oh, you mean like the negative and the positive?
No, I'm talking about X and- Okay, never mind. You just did it.
Okay, all right, we switch the X and Y, and then we gotta get rid of what?
The square root.
Square root.
Square.
So we're gonna square both sides to get rid of the square root. So on the left side, we have
X squared.
x squared, and then we square that square root, they cancel out, and we just have 3y plus 2. Now we still have to get y by itself, so what would be next?
Minus
Or
2.
be minus 2.
Minus 2, good. So x squared minus 2 equals, we're almost there, now what? Divide by 3?
Yes.
The 3 is multiplying the y, so to undo it, we're going to divide. Now we're going to divide everything by 3. We're going to divide this whole thing over here by 3. You could put 3 underneath the x squared and a 2, it would be the same thing. This is a little simpler, and this is the way you will probably see it on a test. So we're going to leave it like this. I'm going to say x squared minus 2 over 3 would equal y, right? Let's just go ahead and replace the y with the function notation f to the negative 1 of x. Okay, did we end up with a square?
Yes.
Yes. Now the next one, well, how is this one different?
Fraction.
Got a fraction. Okay, so in the end, we'll do something a little different. Also, I'm going to do 2 steps in one. I know that this f of x is a y. I'm going to go ahead and switch them. I'm going to have x equals the square root of 1/3 y minus 2. Is that okay?
Yeah.
Right, then get rid of the square root. What do you do? Square it. So x squared equals what? Minus 2. Okay, and then add 2. Okay. So x squared plus 2 equals times everything by 3. So we're going to do times the 1/3 y by 3 and the x squared and the 2 by 3. So what will it be on the left?
3x squared plus 6.
Good. Equals y. These cancel. And then we replace the y with,
Wait, what'd you say?
The function notation.
you had to multiply
Oh, okay.
both of them by 3. Yeah. Okay, so function notation f to the negative 1 of x equals 3x squared plus 6. All right, y'all have 6 problems like this to practice.
Just do
They're-
tomorrow.
No, we're doing it right now, and we're doing something else too.
I've been writing it down.
Oh, I'm sorry. There you go.
Amelia disagreed.
No, Matthew, we're going to do it right now, check it, and move on. Okay, it's not a grade.